Hey, I hope everybody's doing well and you're ready to take some notes. I want you to put down today's objective to use the given information to make conclusions about angles. Now, where are angles going to be? They're going to be inside the circle like this, or they're going to be on the circle like this, meaning the vertex is on the circle, or the vertex is going to be outside the circle. Now, these two, believe it or not, these two have the same rule. This one has a different rule. Okay, so well, I don't know. This one might be a special rule, but anyways, this guy right here. Uh, this is problem number one, by the way. We got a 30-degree angle, 55-degree angle, and I was thinking, like I said, I love circles. I love these angles and all that kind of stuff. Uh, Engines have all kinds of circular moving parts to them. And I'm just looking at the belts here and the pulleys and the different angles that are formed and all that kind of stuff. So this is, not only useful information, it's good for our brain to practice these skills. All right. Now, here's what I did. I made a GeoGebra sketch for you, and I want you to open that GeoGebra sketch up. It looks like this, right? It took me a fair amount of time to get this to work, right? And I was thinking I would do a GeoGebra sketch for the other two concepts, but man, the amount of time it takes me to set this up is crazy. So if have these central angles in here, by the way, and they're not completely drawn, but this radius would go right over to here. This radius would go over to there, and it's 160 degrees at the central angle. That means the intercepted arc is 160 degrees, right? Like this one's 63. The A is kind of in the way. This one's 63.96. This arc up here is 63.96. Now, what we're going to be looking for is what this angle is right here. Well, you can see GeoGebra can measure it for us, 112.43. Well, where does that come from? It comes from the two intercepted arcs, the green one up here, the black one down here. I call them intercepted because the piece of the chord comes over here, hits the circle. The piece of the chord comes over here, hits the circle. And those pieces are making this angle right here. This angle is not a central angle. If they're central angles, it's super easy. The central angle is the intercepted arc up here. But when the vertex is not at the center of the circle, then we've got to follow a different rule. And so we're going to put that rule down right now. And I'd like you to write it down right over here. So let's see here. The angle equals half the sum of the arcs. Okay, so let's color code this a little bit. I'm going to put a little red angle right here, and then let's highlight. I hope the highlighter is clear enough for you. I'm going to turn my highlighter on here, and we're going to highlight the intercepted arcs. So it's this arc right up here is being intercepted by that angle. And then this arc right down here is being intercepted by that same angle. Now you might say, wait a minute. No, it's not, Nelson. The angle is only intercepting that top yellow highlighted one. But remember, they're vertical angles. So this is the same as that angle right over there. So like if they ask us to find this angle right here, it's the same as finding this angle right down here, right? So they're vertical angles. So what we're going to do is we're going to go 1/2 30 plus 55. 30 plus 55. Okay, so that's 85, right? So it's 1/2 of 85. Half of 85 is going to be 42.5, I believe. 42.5. That's how you do the first 6 problems. Now, I made this sketch over here thinking people would, investigate it a little bit, move it around, see if it's always true. I don't know how useful that is, but if you need more evidence that it's the sum of these two arcs, and then half of it is going to equal that angle right there or this angle right down here, keep investigating, keep playing with the GeoGebra sketch. Hey, thanks for following along with my video. Good luck on the homework.